The small moon Enceladus drew attention to itself as the whitest, most reflective body in the solar system. Its surface shows cratering in the north, but the south has giant cracks known as tiger stripes. On Cassini's first loop past Enceladus, the magnetometer team noticed an odd deflection of Saturn's magnetic field, as though the small moon had an atmosphere. During its second pass, the team noticed the same phenomenon. They asked for the next traverse of Enceladus to pass much closer, so Cassini's course was modified to fly just 175 kilometers above the icy moon. The probe passed through a plume of water vapor emanating from the tiger stripes. It contained common salt. In all, Cassini made 24 swoops past Enceladus, with the closest approach flying just 25 kilometers above the surface. Each one of the probe's instruments gathered different evidence about the jets of water expelled through the cracks in the moon's south. On Mars, rovers have been combing the surface looking for traces of life, but Enceladus was flaunting remarkable signs. Gravitational analysis revealed a liquid ocean beneath the ice, and infrared detectors saw heat emanating from the cracks. As well as salt, the science team discovered traces of silica that can only dissolve in hot water. Hydrogen and organic compounds were also detected.
We know from Cassini that Enceladus has a global ocean, so you have water. We also know that there are organics coming out because they've been directly measured, both in the gas and in the particles. We also know there's a source of energy. The South Pole was hotter than the rest of Enceladus. And then we found evidence that deep inside, there are hydrothermal vents on the seafloor of Enceladus. So these hydrothermal vents would supply the heat and the nutrients that could possibly support life.
With a diameter of 500 kilometers, Enceladus is just too small to sustain a hot core via radioactive decay. Gravitational squeezing by Saturn explains some of the heating, but the source of the high temperatures detected remains a mystery.
But not only is there liquid water underneath the surface, but there's organic material, there's a heat source. And you know, when people get excited about the potential for life elsewhere in the solar system, there are four things that you need. You need a heat source, you need liquid water, you need organic material, and you need those three things to be stable over some period of time so that life could potentially form. At Enceladus, we've got three. We're not sure about the stability over time yet.
In the Earth's deep oceans, hydrothermal vents provide the warmth and nutrition to support life. They may even have been important for the origins of life. Planetary biologists are speculating that the environment in the oceans of Enceladus may be the most likely place in the solar system to find some sort of extraterrestrial life.